Good day, viewers. I remain Adeyeye Adelo Peter. Today, we want to look at chemistry. This is our first chemistry class, and the topic before us is oxidation reduction, which is also known as redox reaction. Now, the word redox reaction is a compound word taken from reduction and oxidation. And why do we have reduction and oxidation together? In any reaction where you have oxidation, you must also have reduction. There can never be oxidation without reduction, and there can never be reduction without oxidation. So the two reactions always take place simultaneously. All right, so that is why we have the compound word redox reaction as a short form of writing reduction and oxidation. So what is oxidation reduction reaction? Now, oxidation reduction can be defined in five different terms. The first one is in terms of oxygen. In terms of oxygen. So what is oxidation and what is reduction in terms of oxygen? In terms of oxygen, oxidation can be defined as the addition of oxygen to a substance, while reduction can be defined as the removal of oxygen from a substance, meaning when you add oxygen to a substance, that substance has been oxidized, while when you remove oxygen from a substance, that substance has been reduced. So I am going to be using equations to explain what I mean by that. So for example, if you have copper oxide plus zinc, copper oxide plus zinc. Now definitely we are going to have a displacement reaction, and that's going to be zinc oxide plus copper. So this solid, this solid, this solid, this solid. All right. So these are the reactants on the left hand side of the equation, while these are the products on the right hand side of the equation of the arrow. Right. Now, which one is oxidized? Which one is reduced? So if I draw an arrow from copper oxide, I believe you know that from the left hand side of the equation to the right hand side, copper oxide changes to ordinary copper. So I can draw an arrow from copper oxide to copper. Or better still, I think I should just I should change this to copper plus zinc oxide. All right. So definitely I can draw an arrow from copper oxide to copper, then draw another arrow from zinc to zinc oxide. Definitely we know that zinc turns to zinc oxide. All right. Now from left to the right hand side of the equation, we can see that oxygen has been removed from copper to now give us ordinary copper. From here, copper is having oxygen, but on the right hand side, copper no longer has oxygen. So copper is standing alone, is in the ground state, in the uncombined state. So we can say that oxygen has been removed from copper. So, and according to my definition of oxidation reduction, I say reduction is the removal of oxygen. So since oxygen has been removed from copper here to now give ordinary copper. From copper oxide, we now have ordinary copper. So this is going to be, is that oxidation or reduction? Plus, we are going to have reduction because this is a removal of oxygen. But from zinc to zinc oxide, we can see zinc is standing alone here, while on getting to the right hand side, oxygen has been added to zinc to give zinc oxide. Now we can say zinc has been oxidized to zinc oxide because of the addition of oxygen. So we are going to call this reaction from the left hand side, the right hand side of the equation, oxidation. All right. Now in this equation, you can be asked to state which one is the oxidizing agent and the reducing agent. And I want you to bear in mind that every time in any equation, the oxidizing agent is the one that is being reduced, while the reducing agent is the one that is being oxidized. All right. So the oxidizing agent and the reducing agent can be located on the left hand side of the equation. So for your information, anytime you're asked to find the oxidizing agent and the reducing agent, please always look at the left hand side of the equation, the reactant side, and not the right hand side or the product side. So your oxidizing agent, your OA, which is the oxidizing agent, and your reducing agent, which is Ra, they are always found on the left hand side of the equation, because that is where the reaction is taking place. All right. So we said oxidizing agent is the one that is being reduced, while the reducing agent is the one that is being oxidized. So here, which one is being reduced and which one is being oxidized? All right. Copper oxide is being reduced to copper. So definitely copper oxide becomes the oxidizing agent. OA means oxidizing agent, while zinc has been oxidized to zinc oxide. So zinc becomes the reducing agent. I can use this illustration to explain what I mean by this. You can imagine somebody who was a student who has an uncle who is very rich. An uncle, okay, maybe your uncle sent you to school, and then you can make a demand on your uncle for your fees, for your upkeep in school. Now, anytime you make a demand on your uncle and your uncle sends money to your account, it means the uncle's account is being reduced while your own account is being oxidized. Now, who is the oxidizing agent between you and your uncle, and who is the reducing agent? So you become the reducing agent because you are the one reducing the account of your uncle, while your uncle becomes the oxidizing agent because he's the one oxidizing your account, is the one giving life to your account. All right. So that is the concept of oxidation reduction. All right. So I am going to move to the next definition of oxidation reduction, and that's going to be in terms of hydrogen. So this is the number 2 definition of oxidation reduction. So how do we define oxidation reduction in terms of hydrogen? So I wanted to know that of hydrogen is the reverse of oxygen. All right. So what do you think oxidation is going to be and reduction in terms of hydrogen? Oxidation is going to be the removal of hydrogen, while reduction is going to be the addition of hydrogen to a substance. So when hydrogen is removed from a substance, it means that substance has been oxidized, while when hydrogen is added to a substance, it means that substance has been reduced. So how do I explain that? I can also explain that using an equation. Hydrogen sulfide plus chlorine, for example. All right, will give us I think I should put it on top. I should put it on top. Number 2 now, in terms of hydrogen. So if you have H2S, hydrogen sulfide gas plus chlorine gas to give HCl plus sulfur. All right. Let me balance my equation by putting 2 here. So according to my definition of oxidation reduction, which one is oxidation and which one is reduction? All right, definitely you know hydrogen sulfide turned to, sorry, there's a mistake here, sorry. This is sulfur plus HCl. All right. We are talking in terms of hydrogen now. Which one hydrogen is being removed from and which one hydrogen is added to. So we know that hydrogen is removed from sulfur to give ordinary sulfur here. From H2S, hydrogen is removed. We now have ordinary sulfur. Then chlorine, from chlorine to HCl, it means hydrogen has been added to chlorine. So what is which one is oxidation and which one is reduction according to this equation. So from here to here, hydrogen is being removed. So we can say this is oxidation. So we have hydrogen sulfide there, but here we have ordinary sulfur. So in terms of changes in hydrogen, so hydrogen has been removed, right? Why for this one, what do we have? Hydrogen has been added to chlorine. So this is going to be reduction. All right. So which one is the oxidizing agent and which one is the reducing agent? So we said that the one that is being reduced is the oxidizing agent, while the one that is being oxidized is the reducing agent. So this is the oxidizing agent. Chlorine becomes the oxidizing agent, while hydrogen sulfide becomes the reducing agent. All right. So that's the second definition of oxidation reduction. Now the third definition of oxidation reduction is in terms of electronegative and electropositive element. All right. So what is oxidation reduction in terms of electropositive and electronegative element? Oxidation can be defined. Oxidation is the addition of electronegative element and the removal of electropositive element, while reduction is the addition. So it's just the reverse of oxidation of electropositive elements and simultaneously the removal of electronegative elements. All right. But before you will understand this concept and before I use an equation to explain this, we must understand what electronegative and what electropositive elements are. So what are electronegative elements? All right. Electronegative elements are those elements that have what? The tendency to easily gain electron, to easily attract electrons to themselves, so that when they go into the ion state, they are negatively charged. So examples of electronegative element, I know most of them they are not mostly non-metals. Non-metals. We have fluorine, we have chlorine, okay? We have oxygen, we have nitrogen, and so on and so forth. While when we talk about electropositive element, we are talking about those elements that have the tendency to easily lose electrons. They can easily give out electrons, so that when they go into the ion state, they become positively charged. Metals, generally metals are electropositive, so they are highly electropositive. So for example, we have potassium, we have sodium, we have calcium, we have magnesium, we have zinc, etc. So metals are electropositive element. So when we talk about oxidation reduction, we say oxidation is the addition of electronegative element and the removal of electropositive element, while the reduction is the addition of electropositive elements and the removal of electronegative elements. So let me use an equation to buttress my point. All right, we have sodium plus chlorine. Okay, so sodium, is this electropositive or electronegative according to what I just explained? Sodium is electropositive element. What of chlorine? Chlorine is electronegative element. So this is a metal. while this is a non-metal. So when sodium combines with chlorine, we are going to have sodium chloride, right? Then you balance your equation. Okay. Now, how do I direct my arrows? Okay, from here to here, and then from here to here. No, now if you look at this, you will notice we have just a single product, unlike the ones we have been doing before. We have just a single product, and the single product we have here is sodium chloride. All right, so from here, from sodium to sodium chloride, which one do you think is being added? Now please, let's analyze critically. If you look at the left hand side, what we have here is sodium. And if you now trace this arrow to the right hand side of the equation, we now have sodium chloride. So which one can we say is being added to what? So we can say that chlorine has been added to sodium, because someone who looks at the left hand side seeing only sodium, and then look at the right hand side is seeing sodium chloride. So we can say that chlorine is the one that is being added, because originally what we add on the left hand side is sodium. Now we have sodium chloride. So chlorine is being added to sodium. So according to our definition of oxidation reduction, since chlorine is being added to sodium, so you must ask yourself, what is chlorine? Is it electropositive or electronegative element? So because chlorine is electronegative element, so moving from sodium to sodium chloride, we have oxidation, which is the addition of electronegative elements. Now, the other way around, looking at chlorine on the left hand side, then if we trace this arrow to the right hand side, what we have is sodium chloride, meaning from left to the right hand side, sodium has been added to chlorine. Formerly we had only chlorine, now we have sodium chloride. So because sodium is electropositive, so we can say that this is reduction, because this has to do with the addition of electropositive elements. So from chlorine to sodium chloride, it is reduction. So which one is the oxidizing agent? The oxidizing agent is the one that is being reduced, while the reducing agent is the one that is being oxidized. All right. Now we move to the next definition of oxidation reduction. Number 4. This has to do with electron transfer. Electron transfer. So in terms of electron, number 4, in terms of electrons, all right? So what is oxidation reduction in terms of electron? Oxidation is the loss of electron, while reduction is the gain of electron. Now, how will I be able to explain this well until I join it together with the last definition for oxidation reduction, which has to do with the changes in oxidation number. So I will not be able to write an equation for this for now. I want to skip the equation for this for now. So I'm going to join the explanation of this one with the last one, the most accurate definition for oxidation reduction. That is in terms of oxidation number. Oxidation number. All right. In terms of oxidation number. Now, I think I'm still going to use the same equation I used here for this. So let's look at this. This is going to be sodium plus chlorine to give sodium chloride. All right. So how do I explain oxidation reduction in terms of oxidation number? Oxidation is the increase in oxidation number while reduction is decrease in oxidation number. So what this one means is that when the oxidation number of an element of a substance increases from left to right hand side of a chemical equation, that is oxidation. While if the oxidation number of an element reduces from the left to the right hand side of a chemical equation, that is what? Reduction. Now we have to know the principles, yes, the rules for assigning oxidation number to atoms, to elements, to compounds, to substances, especially in chemical equation. Now, if you look at the left-hand side of the equation, you can see that sodium is alone, chlorine is alone. These two elements are alone. So whenever an atom is alone, an element is alone, in the uncombined stage, not joined together with any element, those elements are said to be in the ground state. So sodium and chlorine can be said to be in the ground state because they are not in a combined form. If you look at the right hand side, sodium and chlorine are combined together to give a compound called sodium chloride. So on the left hand side, sodium in the ground state, chlorine in the ground state, and anytime elements are in the ground state, their oxidation number is equal to 0. So it means the oxidation number of sodium here is what? 0. No matter the number of atoms it has. Then what of chlorine here? 0. Right? So both of them have 0 oxidation number because they are alone. They are not in the combined form. They are in the ground state. Right? Now we must know how to calculate oxidation number for this because this is a compound. Sodium and chlorine are joined together. So how do we calculate the oxidation number of sodium and chlorine here since they are not in the ground state? So since this is a compound, we have sodium chloride. One of the rules for assigning oxidation number to elements says the oxidation number of any for a compound, the sum of the oxidation number of the component element equals 0. The sum of the oxidation number of the component element in that particular compound is equal to 0. So since this is a compound, it has no charge. So the oxidation number of the combined sodium and chlorine together will be equal to 0. But how do we find the oxidation number of each of them as in individually? So we know that the oxidation number of sodium is +1 because sodium is in group 1. And when it goes into the ionic state, is going to have +1 as the oxidation state. All right. So sodium is +1. So this is going to be 1. Then we add that of chlorine, which is unknown. Chlorine is unknown. So 1 plus chlorine equals to 0. Then you make chlorine this solid of formula. So this Cl is standing for the oxidation number of chlorine. So chlorine, if you correct like times, is going to be equal to 0. Carry this one here, -1. So that chlorine is equal to -1. So the oxidation number of chlorine is -1. So please don't mind the number of atoms we have here. So this one doesn't really matter. So just pull out only the compound and find the oxidation number of the component element. So it means sodium is +1 while chlorine is -1. All right. So from the left to the right hand side of the equation, we can see that sodium is 0 while on the right hand side sodium is plus. So what do we call that? That is oxidation. So if I draw an arrow from here, if you can remember that when I drew the arrow the other time from here to here, from sodium to sodium chloride is oxidation. That's increase in oxidation number. While from chlorine 0 to sodium chloride, now chlorine goes from 0 to -1. That is what? Reduction, because that is decrease in oxidation number. From 0 to -1 is decrease. So this is what? Reduction. So now, the reason why the fifth definition of oxidation reduction is the most accurate definition for oxidation reduction is because in any reaction, in any redox reaction, you must always have changes in oxidation number for the component element, either increase or decrease. As one element is increasing in oxidation number, the other element must decrease in oxidation number. But you cannot use hydrogen to define to define oxidation reduction for some reactions. You cannot even use oxygen. Look at this equation, for example. There's no hydrogen here, there's no oxygen here. So the definition of oxygen and that of hydrogen is highly limited in this equation. But you can use the definition of oxidation number, the changes in oxidation number, to determine whether you have oxidation or reduction in this reaction. All right. So I said I will use this same equation to explain the changes as in gain and loss of electron. Now, if you look at sodium here, sodium, the charge on sodium here is what? 0. The charge on chlorine here is 0. But if you are to write the ionic equation for sodium chloride out on the right hand side of the equation, this is what happens. Sodium is going to be plus, while chlorine is going to be minus. So from the left hand side to the right hand side of the equation, I can say sodium gives Na plus, while chlorine atom gives Cl minus. This is what we have on the right hand side of the equation. While this is what we have on the left hand side: ordinary sodium and ordinary chlorine. All right. So if I'm to break it down again, so what can we say actually happened? Now, if I balance this equation, I am going to have sodium to give Na plus, then you balance it, you put plus E minus, all right? While chlorine, to balance the charges for chlorine, this Cl minus, what do? I put an electron here, all right? This electron cancels this positive charge, so we have zero charge, just like we have zero charge here. Then there's a negative charge here, so adding electron here will also make us have a negative charge on the left hand side of the equation. If you add this electron here, it can't cancel out this, so we are going to have -2 charge here. We are going to have two negative charges here, so you have to add the electron to left hand side of the equation to balance your charge. All right, and anytime you're balancing charge, we always add electron, so either to the right hand side or to the left hand side, as the case may be. All right, so from here to here, we can say this is loss of electron. This loss of electron. While from here to here, we can say this is gain of electron. So chlorine gains electron here. Chlorine, which was formerly having zero charge, now having a negative charge. So that is what? Reduction, because it has gained electron. While sodium has lost electron, it is neutral here, no charge here, zero charge here. While on the right hand side here, sodium is now having a positive charge. So that is loss of electron. All right. So this is oxidation, while this is reduction. So thank you so much. Like, comment, share, and please make sure you subscribe. Thank you and God bless.